Hey everyone, welcome back to blenderdiplom.com. I'm Gottfried Hofmann, and this time we're gonna create a really cool thing. We're gonna create our own reusable cycles shader for absorption. And what's all this absorption stuff about? Well, take a look at this demo file I got here with a gender-neutral chess piece created by Frank Bauer. Thanks for that. Well, on the left I got the default cycles transparent shader, and you see the chess piece has always the same amount of transparency no matter how thick it is. So the parts here actually should look a lot darker than the parts at the bottom, at the top. Same goes for the default glass shader. It's got the very same problem. It has always the same amount of transparency no matter how thick our figure is. But what we want is the shader on the right. That's the one we're going to be creating. That one has parts that are thin and they are way more transparent than the thicker parts. And here you can have a look at the shader we're going to create. It looks complicated, but I hope after the tutorial, after you watched it, you'll fully understand it and it won't be as complicated anymore to you. It's also something that you'll learn to create shaders from physically formulas you might find in physics books or on the internet. So this will be something really useful, and stay tuned. Something that will be really cool about the shader we're going to create is its customization and reusability. Let me just show you the demo. I got here the transparent BSDF, and we'll create a shader that can easily be added by selecting right next to the color panel or create a node group we're going to create. And there we'll have a base color we can change and an absorption color. It can easily also be something different, and an absorption coefficient that will tell us how much to absorb. That's really customizable. You will be able to create lots of different absorption effects, and it will also work on both the transparent BSDF as the glass BSDF, which is already looking cooler, and also on the translucent BSDF. So very cool stuff we're about to create. So let's go down to the dirty details. So let's start right with the basics of how cycles is using light. That's a so-called path tracer, and it's just shooting rays from the camera and checking what's happening while the light is traveling through our scene. For example, here it's hitting a surface and it's a glass surface, so the direction is changing. Then there's the other side of the surface, direction is changing once again. Light keeps traveling, and at this point there might be some color information for the glass, so it notes, color is changing. Then it's traveling through there, and a lot of other stuff might happen in the scene until the ray hits a light. And that's when it's going to terminate and return to cycles the information of how much light there is at the point where it's reached. And you'll already notice the problem maybe. Currently, cycles is just handling, okay, there's a surface, it shoots through, there's another surface, but it does not know whether anything is happening between these two surfaces. And that's because cycles doesn't have volumetrics yet. So if you want to create a glass that's actually absorbing light, we need to tell cycles what to do in this part of the path, right here. And we have to tell them that the longer the path is, the longer this part of the ray is, the more absorption there will be. So how can we achieve this? Well, there have been numerous people around the world over centuries checking out how the world around is behaving and working, and they found out a lot of stuff. So let's just see whether we can find anything out about absorption. And when you're looking at absorption in optics or physics, you'll probably find the Beer-Lambert law. And it's just a law that relates to the absorption of light to the properties of material through which the light is traveling. Bingo. That's exactly what we want. Beer's law. And here we also already got some formulas, and that's already sounding pretty cool. And we will take the bottom one with the E, and not the top one. They're interchangeable, but the bottom one will just be a little bit easier to implement. So we got this T. This is the transmissivity, and that's related to E part to the power of minus, then this here, this small piece, and this here, and L, which is the length of the path. So this is something we got here, and that's something we can compute now in Blender 2.64 thanks to the ray length node. So we got it. What else do we need? We need these two things here, the N and this Greek one, which is N reads as the density, and this one is the absorption cross-section, and we can just combine them to one number, the so-called absorption coefficient, because you know when you multiplicate two numbers you get another number. So let's just combine them, because we don't want to compute the really exact kind of absorption unless you're really that much into physics that you want to calculate how much molecules are there in your material and what's there and how are the molecules absorbing the light. And then you could of course use both numbers, but we'll combine them to one and choose an artistic number that will just be how much there will be absorption in general. So we have already made the formula a little easier. And now let's have a look how this formula is looking, or what this formula is actually doing. So let me add something that's an add-on. Under add mesh, if you turn on the add-ons extra objects, there is under math function set math surface, and that simply means that we have a three-dimensional surface. We only use 2 dimensions, and we can simply add formulas there down here. Let me first add just 1, and we'll see up there 1 Blender unit away from the floor there is now our surface, so 1 is actually 1 Blender unit. Now let's start adding all this stuff. We got the E, which is just a number, it's a constant. Let's write it here. And here you'll see it's 2 point something, that's okay. And we need to have the power of something in E, and that's in Python just 2 times the sign for multiplication. And let's choose just the minus, so e to the power of -1. And of course, not much has happened yet, because we also have to add the length of our array, which will be, in this case, the x-axis. So let's add it. -1 times x. And there we got our formula. And the 1 can actually be any constant. This will be our absorption constant. We got the minus, we got our ray length, that is x. And this will just tell us how things are behaving in our material. So we see when we are at the first part of our material, the first surface, there is no absorption, of course. Then there's absorption, and it's behaving in this kind of way. So the longer we travel through it, the more it gets absorbed, but it's a logistic function or logarithmic function, so the absorption gets gradually less and less and less. And if we get a material that's very, very big, then there will be more and more absorption. Let me just increase the size of this. And at some point, this will be absorbed so much that we can't see anything anymore, and our object will like a solid diffuse surface. So this is how this formula is obviously working. Not that complicated, fortunately. But now our question is, how can we get this stuff into a cycles shader. First thing we need to find out is how can we control the absorption of transparent materials in cycles in general. Here I got a default transparent material, and we've got only one thing we can change. It's the color. So this probably means that all the stuff like the amount of transparency is all coded in the color. Let's see. If I make this purely white, it's completely transparent. And if I make this completely black, it's totally opaque. So obviously, this is what we need to control the amount of absorption. It's the darkness of our object. But there's also more to it. Let me switch to HSV. Here we got the darkness down here, but we got also something else, and that is the saturation. So obviously the amount of absorption is also taken, as it's also computed by the amount of saturation we got of our color. So these are the two things we'll have to have in mind. And the one up here is just the tone of our color, the hue. So let's make this pretty basic at first. Let's create a shader where only the darkness plays a role in the amount of absorption. So we'll just change the darkness at first to get our absorption. How can we do this? Well, how can we change the darkness of our material dependent from any kind of formula? Well, we can use a color mix node for this. And simply mix a color with black. So let's give this just some random color here. That's very bright. And we already see this is mixing our two colors together based on this factor value up there. If I turn the factor down to 0, it will all be the top input, the black. And if I turn the factor up to 1, it will completely in the color of the bottom input. So this is how we can control our amount of absorption. And the cool thing is that our formula will spit out a value between 0 and 1. So this is perfect. Let's just use the factor value. So now we've already managed the most tricky part of our formula. And that is what we got now is we got the T equals. So what's left is just this stuff here, and that's just a bunch of math nodes put together. Let's start from the left. We got e to the power of something. What do we have in cycles for this? Well, under converter, there is the node called math. And here we got a lot of stuff. We can use a lot of formulas. And let's look for power. Here it is. Put it into the factor value, and up here, let's select not the exponent, but the base. That's e. And it's automatically calculated the right number for us. And as the exponent, we can have pretty much anything. So this is where we're gonna add, in this slot is where we're gonna add all the stuff but above here. Let me duplicate this math node with Shift and D, connect it down here, and let's first select multiply and -1 with something else. So we got the minus, and the 1 down here is actually our constant. But let's use for the constant another math node, because we'll also need to multiply the ray length. So let's put the constant up there. Let's call it 1.5 for the beginning. And down here, the last thing we'll need to add is our ray length. And that's something we get in cycles pretty easily now, thanks to the ray length node. But there's one tricky part left. Let me first show you where you can find this omnious ray length node. It's an input light path ray length. But if we plug this down here into our multiply, it will go completely black. And that's simply because the array length doesn't know how big your object is. Basically in cycles, when an array hits a surface, it's changing its type. In this case, it will, if this is glass, it will change to a transmission ray, but it will shoot through and it will still be a transmission ray. So obviously we need to tell the ray length when to stop at the other part of your surface. So it gets in, traverses, and at the other surface it should stop. And for this, there is input geometry backphasing. You might know backphasing from problems where you have an object with two sides and you want the two sides to have different materials. That's where you can use backphasing. But you can use backphasing also in conjunction with the light path and those rays here. And if you multiply this with an array, you'll tell it when to stop when it hits a backphase. So let's use another multiply node, Shift-D, multiply the backphasing with the ray length, and yeah, here it is, our shader. All we did was find this formula, translate it into cycles nodes, and the two tricky parts were to find out how to handle the absorption. The solution was a mix node, and the other tricky part is to tell the ray length node when to stop. So we only get the length of the ray when it's traveling through our transparent object. So here it is, our shader. Pretty cool, eh? Let's first have a look at what we can do with our shader right now. First of all, we got the transparent BSDF, but this is interchangeable. We can change it to glass or translucency. So we'll probably want this to be to change this later on. But I want to hide all the other stuff here, because if I give this shader to another artist, I don't want him to see all the stuff. It will make him confused. I want this to be very clean, so he just has some stuff to play around with, 3 inputs, and that's everything. So let me create a group from this by using Ctrl-G. Make a new group. Now we got a group here, and it's very simple. It's not no longer this big shader tree, but just one node. But there's still one thing I'd like to change. And that's right now, if you use this group, you still have to open it up to change the values. And that, of course, will once again confuse your artist. So let's see what values we got here, so we can put this onto the left side and allow a simple interface for our node group. First, we got the base color of our material. So let's put it up there and call it base color. And let's also give it a default input of pure white. Then we got a color to mix it based on the absorption. So let's put this here and call it absorption color. And then we got a third thing, and that is here we got our constant that tells how strong the absorption is. Let's call this absorption strength, or just strength. So now if you close this node group, you'll see we got our 3 things, our 3 controls. The base color we can change just as we want. The color for the absorption. Let me just change this to maybe some green. and the strength of our absorption. So let's crank this up to maybe 3. And now we can also simply use another shader. Shift B, deselect this. Here, for example, we got our glass shader. And now we can also select our group right here on the color, node group. And now we got our base stuff, and we can do all the things we can do with our shader, we can do here too. Pretty cool, right? And let me go into a new node group one last time and call it something different, like absorption shader. So what can we do else can we do with this new group we've just created? Well, we can use it in other projects. So let me save this for now, create a new project, and let's use Suzanne as an example. Shading smooth, go right to the camera, go down here, select rendered, and right now Suzanne has a default diffuse material. Let me select the Suzanne and head over to the materials panel, give it a new one. Let's select glass. And now we want to use this absorption shader. Well, it's pretty simple. Go to File, Append, and well, here I got the blend file I've just created with the absorption shader. Let me go into the blend file, there on the node tree, absorption shader, link append from library, and now we can use it here. Wow. That's something that's really cool about this shader. You can use it in your project whenever you want, and you can do cool stuff with this. Like for example, this glass shader, which is actually transparent, but it becomes, the thicker your object is, the more gets absorbed towards this color and everything. And also something about the technique you learned right now today with the ray length is that you can actually use this to fake subsurface scattering using the translucent BSDF. But that's something where you would still need some work on the shader. You will still need to change it, but maybe you find it out here yourself, or check out blenderartists.org, where people have pasted lots of cool subsurface scattering shaders using cycles. And yeah, maybe I'll do a tutorial about it too. Lastly, 2 things you should know about the shader you've just created. First, let me duplicate this piece here. And as you see, if you got your mesh intersecting with another one, the shader will get confused due to the back-facing node we got here, so you can only use it for good results when your meshes are not intersecting. But as you see, it's working pretty good when your meshes are behind each other, because the absorption gets added up. That's exactly what we want, and how things would behave in the real world. That's pretty good. But now let's have a look at this top part here, where we got these strange black holes. And those are not due to the shader. They are a problem in the transparent material itself. And the problem is that when you get too many intersections, cycles will just stop looking for a light source. And the amount of intersections that are allowed can be set down here in light path. And there we got under transparency, the setting in the default, it's 8. That should usually be enough, but you see here it's not enough. The light is traveling to way too many parts. So let's see what's happening when we are increasing the value. Things start to clear up and we get the right result, but it's rather noisy. That's because we need to set both to the same value. Otherwise, cycles will just randomly terminate the rays and we'll still get this black part. Now, so if you got these black dots, just increase your transparency bounces and everything will be fine. And the reason why this is black is because, yeah, if a ray traverses and it stops before hitting a light source, it will just be black. So this is it, folks. have fun with the new features in Blender 2.64. And if you create anything cool with the ray length node, just let me know on blenderdiplom.com. Drop a comment, show me your work. I'm really interested what you're doing with the stuff I'm teaching here. And also, maybe you'll find a better way how to do this. Then also just drop a comment, show me a setup. I'm always interested in other people's solutions for problems. And maybe you just found a plain error in the tutorial or something you don't like. In this case, you can also leave a comment, because I'm always open for criticism to improve the tutorials on Blender Diplom. So have fun everyone, and happy blending!